For Chapter 9, Section 6, we are going to be talking about another way to solve these quadratic equations. This one is going to be solving it by doing something called completing the square. So there's going to be times when graphing or factoring, some of those methods that we've talked about so far, is not necessarily the best or most effective way to solve. And sometimes there's some equations that we actually can't factor. So back in Chapter 8, when we were practicing factoring, we saw some examples of those where we had problems that we had to say prime for because we weren't able to factor them using the methods that we knew at the time. So we're going to continue to talk about completing the square so that we can kind of see another way to solve these quadratics in case you can't factor them or graphing is maybe not the best option. In order to do this, we need to have what's called perfect square polynomials. So you want to have terms that you can rewrite the left-hand side with, like we did on this example. So we started with that 4x squared plus 12x plus 9, and we rewrote it as 12x plus 3 parentheses squared. And so that showed up when we were factoring last chapter. We saw some of those examples where we were talking about like those special cases where we had like perfect squares or like the difference of squares. And so we're able to rewrite that left-hand side by kind of factoring or square rooting the first term, so square rooting that 4x squared into 2x, and square rooting the 9 into 3. Because then if we multiply those terms together on the inside and you double it, then you're able to get that middle term. So that's kind of one of those special factoring problems that we had talked about back in Chapter 8. Because when we get to this point, like we saw in Section 5 when we were solving those inverse functions, in order to get rid of something that's squared, we want to square root both sides. And so you can kind of see that that's what they're doing here to get to this point. When you square root the left-hand side, the square and the square root are gone, and so you're left with 2x plus 3. And the square root of 16 is going to be plus or minus 4, because again, when you square root something, there's always that positive and negative side. So when you go to set up your equations, you have to set the 2x plus 3 equal to a positive 4 and set it equal to that negative 4. Then you're looking at trying to solve these just using your algebra skills that you guys have done like all year when you get down to an equation like this. So to get 2x by itself, we subtracted 3 on this one. So they got 2x equals 1, and then they divided by 2. And so they got that x equals 1/2. Over here on this side, they still subtracted 3, but this time it's set equal to a negative 4, so negative 4 minus 3 is how they got that negative 7. And then they still divided by 2, but they got negative 7 over 2 for their answer here. So if we were to graph our equation here, like if I came back up and I wanted to graph this equation, these 2 points is where it would cross the x-axis at. So these are your solutions, or these would be known as like your x-intercepts, because that's where it would cross the x-axis at. Okay, so let's do a practice problem here. So you're going to want to rewrite this one on the left-hand side using that same process that they did before. So if you think about x squared plus 6x plus 9, if we square root the first and we square root the last, then you're going to have x plus 3. And then if we square that, that should represent here the equation on the left, because again, if you take 3 times that x and double it, that gets you that 6x in the middle. And then we're going to have that set equal to 4. So take a second here, square root both sides, write out what would be left, and then go ahead and solve for your 2 solutions. So on the left-hand side, when you square root that, you're going to be left with just x plus 3. And then it's going to be equal to a positive and negative 2 when you square root that 4. So now when you set up your 2 equations, one of them's going to say x plus 3 equals the positive 2. The other side should say x plus 3 equals the negative 2. So I'm going to subtract 3 from both sides, and I'm going to do that on both of these equations here. And so my 3's will go away, And for this first one, we have 2 minus 3, which would be negative 1, so there's one answer. And then for this side, we have negative 2 minus 3, which would be negative 5. And so there's that answer. Okay, so let's talk about how we can do this process for other types of equations that maybe you can't just automatically factor the left-hand side like we saw in those last two. And so this is when we're going to get into that process that's called completing the square, so we can see exactly how this is going to work. So remember when we had a quantity like this squared, that meant that you were taking it times itself. And so we're kind of showing you that rule that we had talked about in chapter 8, where you square the first term, you multiply the pieces on the inside and you double it, and then you square the last term in order to get your equation. So for completing the square, if we had something given to us, like what we have down here where it says x squared plus 16x plus this blank. So there's going to be times when they don't give you kind of the piece that you need in order to be able to write it out factored all nicely like that. What we have to do is figure out like what term goes in here. So to do that, we're going to take the middle term, so that's 16, and we're going to set it equal to 2d, because that's going to be taking half of the middle term. Because what I want to find out is what is that last term that I have to square times itself. So we divide by 2 here. 16 divided by 2 is an 8. And then you square 8 to get your 64. And so 64 is what would come up here into the blank. So I do that process by just taking that middle term. You're going to cut it in half. And then you're going to square that in order to figure out what goes up in that blank. Because then this would be the same thing if I wrote it like this. X plus 8 quantity squared. Which you'll see that they did down here. And the reason why they do that is to make sure that then you would be able to square root both sides like we were doing on those previous examples. So let's go ahead and practice that. So I just want you to find the term that goes into the last blank. So I want you to do this one, and then also try to do this one and see if you can find out what is supposed to go in that last blank in order for you to be able to write out as it a quantity squared. So the steps you need to take is just to take that middle term, 12 for this one, divide it by 2, which would be 6, and then you need to square that. So 6 squared would be 36. That's what should go in the blank here. So that if I needed to, I could rewrite this as x plus 6 quantity squared. So let's do that same thing on this one. Your middle term is that negative 6, so you're going to take negative 6 divided by 2, which would be negative 3. Now, even though it's negative here, that's not going to change anything when you square it, because remember, a negative times a negative is still going to end up making that positive. So that's why you can always have a plus sign there. So that comes out to be 9. So we put 9 up here in our blank, so that if I needed to, I could write this one as x minus 3 squared. Okay, so now I'm going to show you kind of the whole process where we start with what we were just doing there to kind of rewrite that left-hand side, and then I'm going to show you what do you do to the other side of the equation to finish this off so that you can actually find your two solutions. So the steps that you want to follow is if you have a number given to you, so if your equation says x squared plus an x and then a number, you want to move that number over to the other side first. So you want to get the x squared and the x terms kind of by themselves because we're going to isolate them so that we can do our completing the square process. So move your constant term over to the other side of the equation, so to the right side. Complete the square on the left side of the equation. So do that process that we were just doing. Take half of your middle term, square it to kind of fill in what we'll call, like I'm going to refer to them as blanks because we're going to be rewriting these equations where we can fill in that piece for that completing the square. Now when you do that to the left-hand side, you'll also have to add it to the right-hand side. That way you can keep your equation balanced. And then we'll solve it like we did at the very start of class, where we can write it as a quantity squared, and then we'll square root both sides. So for example, here I have this x squared plus 6x minus 16. The first thing I need to do is move this minus 16 over to the other side. And so we do that by adding 16. So then after I move 16 over, when I rewrite my equation, you'll see that I already have like these blanks drawn in here. And I'm going to do that for all of them, because that's where my completing the square piece is going to go. So we've got x squared plus 6x plus a blank, and then we move that 16 over here to the other side plus another blank. So to find that term, remember what you're going to do is take 6, the middle term, you're going to divide it in half. So you're going to take 6 divided by 2, which would be 3. So to find that third term, we're going to take 3 and we're going to square it to get us 9. So 9 is what's going to go in my blanks on both sides of the equation. You can see that they wrote those down here as well. And again, because we're doing it to the left-hand side, we have to do it to the right-hand side so that we keep the equation balanced. So now on the left-hand side, we can rewrite this as the x plus 3 squared. Again, that just came from square rooting the x squared, square rooting the 9. It's also going to always be the same number that you found that you put here. So whatever that number is, whether it's positive or negative, is what's going to come down here into your parentheses. So this one we rewrote as x plus 3 quantity squared. And then equals 16 plus the 9 is how they're getting 25. Then what they're going to do is finish solving this, so you can see how they square root both sides to get rid of that exponent of 2. And when you square root the 25, that's going to leave you with a positive 5 and a negative 5. And then we solve these two equations. So I'm going to subtract 3 on both of them. So you're going to have 5 minus 3 over here, which would be 2, and negative 5 minus 3 over here, which would be negative 8. So your solutions would be 2, 0, negative 8, 0, because again, those would be the points where your graph would have crossed the x-axis if we were looking at the graph. So if you want to try this practice problem, go ahead and do that for a minute, and then continue watching the video here to see how you should have gotten your solution. So step 1 is to move that constant over to the other side. So we're going to add 20 over. So now it says x squared plus 8x plus a blank. And now we've added 20 over to this side. So we have positive 20 and then plus another blank. To fill that piece in, we're going to do our 8 and divide it by 2, which would be 4. And then you have to square that. So 4 squared, 4 times 4 would be 16. So 16 is what goes up in your blanks. To rewrite this left-hand side, you're going to have x plus the 4 squared. And then over here you have 20 plus 16, which would be 36. Now we square root both sides. So on the left, you're left with x plus 4. And then equals positive negative 6. The square root of 36 would be 6. So setting up our two equations, we'll have x plus 4 equals positive 6. X plus 4 equals negative 6. To solve both of them, you're going to subtract your 4's. So one answer is going to be x equals 2, and the other answer is going to be x equals negative 10.